Hi, this is the second video of the series Geometry and Nearest Neighbors. And in this video, we are going to learn how to transform data into feature vectors. From the previous lesson, we have learned that an example is just a collection of feature values and that an example can be written out as a vector. A vector representing a point in a high-dimensional space where one feature corresponds to one dimension. Let's say we have an example that is in a form of a course review. One feature might count how many times the reviewer wrote the word nice. Another might count the number of exclamation points. For us humans, these features have meaning because we can make sense of it. But to a machine, the features themselves have no meaning. To a machine, only the feature values make sense. From this perspective, we can think of an example as a feature vector consisting of one dimension for each feature where each dimension is simply some real value. This is how you map real valued features into a vector. Mapping feature values that are binary in nature is also very straightforward. Since we simply denote yes and no values to zeros and ones, then we simply write its corresponding vector this way. Things get a bit complicated when it comes to categorical feature values. Let's say our feature value answers whether an object is red, blue, green, or black. One option is to map red, blue, green, and black to 0, 1, 2, and 3 respectively. Though you may think this is not entirely bad, but the problem is we are mapping unordered values to an ordered one. When we use these features and measure examples based on their distances to each other, this mapping will tell us that red and blue are more similar than red and black. This is not what we actually want. A solution is to turn them into binary features. That means we simply convert the features into questions answerable by yes or no. We can then use these binary feature values to represent a vector. So an example would be a vector 0, 1, 1, 1, which means that it's not red, but it is at the same time blue, green, and black. With that in mind, we can then use the following mapping to map a dataset into feature vectors. If the feature has real values, then just copy the real value. If the feature is binary, use 0 and 1. For categorical features, we just convert it to binary first, then use 0 and 1. After this mapping, we can then think of a single example as a vector in a high-dimensional space. If you have d many features, then the feature vector will have d many components or dimensions. For 2 dimensions, feature vectors are just points in a plane. For 3 dimensions, feature vectors are in a cube. It gets a little tricky for 4 dimensions, and we need to avoid the temptation to think of it as time. Unfortunately, for the kind of problems we're going to encounter in machine learning, dimensions of around 20 are considered to be low dimensional. 1000 dimensions are medium dimensional. What problems are considered to be high dimensional are those features which generates or gives us dimensions of 100,000. Now that we already know how to transform our data into feature vectors, in our next video we are going to learn the nearest neighbor algorithm. See you next time.